So it's frustrating for me that the last video I showed you that the numbers didn't work out perfectly. I'm going to try to do a setup here that's going to make it easier for you to understand. We have 4 or 5 100 ohm resistors here. We have a 6-volt power supply. So to calculate this, well, first we'll go through and we'll do everything. We'll measure for everything. So let's measure for voltage total. So I'll hook my negative side up to my first resistor and my positive side to my 5th resistor, and I will set up to measure in voltage. And I'll put this down here right now so you can see it. Set up to voltage DC, and come across those ends. So I'm getting total 6.25. So voltage total measured is 6.25. Current measured, I have to change to my ammeter, and I'm going to measure the current as we're coming in here. So negative, positive, 12.6 milliamps. 0.6 milliamps. And when we're using Ohm's law, we're going to have to convert that to amps. So that's going to be 0.0126 amps. Right? I moved it over 3 spaces for the amps. And now we'll go to resistance total. So the power supply gets taken away from the circuit. And I go to ohms. And I measure what the total resistance here is. It's 5 100 ohm resistors, so it should be about 500, right? 5.53 kilo ohms, which is 532 ohms. Okay? Slightly off of what it really should be, but when we said these 5 are connected here, if I connect into those 5, we should have 0 resistance, but we have 20 ohms of resistance. If I just touch the leads together, we have 19.4 ohms of resistance. Let me turn this off and then on again. Here we have 2.2 ohms resistance. So let's measure the total resistance again. .520, so 518 ohms. It's a little bit better than 532, 518. If I stick it in those two there, the coil down there is offering no resistance in that spot, but I have seen some coils down there as springs that are offering much more than that. So now we'll go to R1. Measure the value of R1, 100 ohms. Measure the voltage. Now again, we have to put the power supply onto this. Negative, positive. Switch over to voltage, direct current. And we get 1.23 volts. 3 volts. And we measure the current there. Same thing we just did right before the resistor. Go to the ammeter. 2.6. So it's the same thing here, 0.0126 amps. So the laws that we've talked about so far in a series circuit, that the voltage is going to get divided. 6.25 is divided up into five parts there. So 1.23 makes sense for voltage. I'll make sure I write my units here for you. Our current should be the same throughout a series circuit. So that makes sense again that we have the same current. And our resistance here is 100 ohms. So now we're going to go through, we're going to calculate these using Ohm's law. Okay? I'm going to set all of this back. And I'm going to redraw our wheel. This should be in your notes. This is Ohm's law. Ohm's law equation says that in this, if we're looking for resistance, we'll divide voltage divided by current. So we know that we're working with, this is all in theory now again, we have 6-volt power supply, and we have 500 ohms of resistance. So if we want to find out, because we don't know what the current is, we know what our power supply is, and we know the resistors that we have in here, we can add those up. So our current would be 6 divided by 500. .01. So that's not too far off, right, of what's supposed to be 0.0126. So we're correct with that with our amps here. Now if we go to our individual resistor, we have our voltage, our resistance. We know our resistance is 100. We know our current is 0.01. So let's use it the opposite way to figure this out now. So if we want to find out what the voltage is at the voltage drop at our first resistor here, now we go ahead and use the equation again, and we cover up the one that we want, voltage, and it's I times R. We multiply across and we divide top to bottom. So I'll take those numbers, 0.01 times 100 equals 1. So it should be about 1 volt, which is going to be dropped or pushed across R1 to get that, which is not perfect, but it's close. Okay, so this is Ohm's law, and I'm going to give you guys some questions for that in just a moment here. I'll send that out to you next.